would like to find out everything there is to know about this parabola and sketch its graph. We can tell it's going to be a parabola because it's a quadratic equation. I have x squared equals y, which is the form of a quadratic equation. All quadratic equations have graphs that look like parabolas, so I know it's going to be a parabola of some kind. My coefficient out in front here is positive 3, so my parabola is going to be opening up. I don't know exactly where it is or how big it is, anything like that yet, but I can tell it's going to be a parabola opening up just by looking at the equation. Parabolas have a vertex, so let's find the vertex. It's nice when we're in this form. This is kind of transformation form of the equation of a parabola. I have x minus 2 tells me the whole thing is going to move 2 to the right. So my vertex, x equals positive 2, and down 3, so y is negative 3. My vertex, again, really just from looking at the equation and knowing how these work, 2 to the right and down 3. And there's my vertex. So 2 to the right, down 3, vertex, there it is. Got a point. That's a good start. Let's find some intercepts. My y-intercepts, I'm going to find, as always, by making x be 0. So y equals 3 times x is 0, because any point on the x-axis has any point on the y-axis has an x-coordinate of 0. Everything else is the same. Minus 2 squared minus 3. Then we let the order of operations take over. 0 minus 2 is negative 2. Negative 2 squared is positive 4. Multiplication is next. 3 times 4 is 12. 12 minus 3 is 9. So I came up with 9. My y-intercept is a point. Has 2 coordinates, x and y. X is 0 because we made it be 0. Y is 9 because we calculated it. So 0, 9 is my y-intercept, and then we're going to put that right here. I could put 9 little hash marks, but I'm not going to. So, and then actually from there we also get a point for free. We know parabolas are symmetric about the vertex. So if I have a point at 0, 9, 2 to the left of the vertex, I get a matching point, a distance of 2 on the other side of the vertex with the same y value, so that's 4, 9. There's another point. I got 3 points. We're off to the races. Let's find some x-intercepts. We're going to find x-intercepts by making y be 0. So I'll have y is 0 equals 3 times x minus 2 squared minus 3. That's a quadratic equation. We can solve it by factoring over the quadratic formula, and to do either of those, I gotta fix this. That's not in a nice form. I want to have ax squared plus bx plus c. So let's go ahead and multiply out. X minus 2 squared is x minus 2 times x minus 2, x squared minus 4x plus 4. If you can do that in your head, that's wonderful. If you can't, write it out. X minus 2 times x minus 2, and that's what you should get. Now I'll distribute the 3 through there. Minus 12x. And then I got 3 times 4 is 12. 12 minus 3 is 9. That looks better. I'm not a huge fan of the 3 coefficient out in front here. Fortunately, I'm going to notice I can factor 3 out of all my coefficients. I have a common factor, so I'm going to factor out 3. So I got 3 times x squared minus 4x plus 3. If I divide both sides of this equation by 3 at this point, on the right, when I divide by 3, it will go away. I have 1. On the left, 0 divided by 3, still 0. So I'm just going to factor what I have here. That will factor. I got, let's see, I think x minus 3 times x minus 1 is going to do the job. Negative 3 times negative 1 is positive 3. Check. And negative 3x minus 1x is minus 4x. Check. Yep, we're good. So then I'm going to set each factor equal to 0. X minus 3 equals 0. X minus 1 equals 0. And solve. So I'll get x equals 3 and x equals 1, which means my x-intercepts, again, intercepts are points. They have 2 coordinates. So I'm going to have 3, which I got by making y be 0, and 1 and 0. 2 points, 2 x-intercepts. So 3, 0, right there. 1, 0, right there. Now I have really more points than we need. And we've found about everything that we need to know in order to graph this parabola. We're going to connect the dots. We know it's going to be a parabola shape. Parabolas are never pointy. It might be tempting to come down to the bottom here and make it sort of look like a V, but it's not. Parabolas are more of a U shape, nice and smooth all the way. And that's not the world's most beautiful parabola, but it'll do the job. So there's our graph of this quadratic equation.